Hey guys, welcome back to the shop. I got another job here to do for the welding shop. They've got a bunch of these pieces of angle iron that they want some holes put in. So these pieces are 4" by 4" by 1/2 inch thick angle iron, and they simply need 2 holes put in there. So they want some 13/16 diameter holes, which is going to be a clearance hole for a 3/4 inch bolt, and they're going to be 1 inch from the back in and 1 inch from each end. So these are 6 inches long, so we have a 4" center to center hole pattern to put in there, and it's as simple as that. That's what they want done. There's going to be more of them to pick up, but they had these cut yesterday, so I went ahead and picked them up first thing this morning so I could begin my setup, begin the program, begin the setup, and go ahead and start getting them knocked out. Should be fairly simple. We're going to do this just like that other recent job we did with the 2" pins where we drilled the holes. So I plan on having 2 work offsets in there. We'll drop 2 of these pieces of angle in, tighten them up, hit cycle start, and we should be able to get 4 holes put in there, pull them out and keep it going. But this time around, instead of drilling a hole with a drill bit, I'd like to try something different. So I have one of my Tungaloy end mills here. This is a Tung Force Rec end mill, and this is the smallest one I have, which is a 1/2 inch diameter. These are sweet little mills right here. I've shown these many a times. They work really great in manual mills as well, but these guys are awesome because you can use them as an end mill. You can plunge, so you can ramp down with them, and they're high speed, high feed end mills, so you can really move some metal really quickly with these guys. So my idea was use this 1/2 inch Tung Force Rec mill and just come in here and do a helical pattern down to cut our hole size, just like that. It's another job where it's calling for a 13/16. I don't have a carbide drill. I do have a high-speed drill that we could use. I know how that goes, and it'd be just fine, but I thought I would try something different. And maybe it'd make the job go a little bit faster and maybe a little bit more fun too, because I love watching these guys work. These Tung Force Rec, you can get them as small as 3/8 diameter and up to 1 inch, and I believe over 1 inch they have, it's like a face mill head that you bolt on at that point. But I love these little mills, so let's see if we can make our 2 13/16 holes in these pieces of angle iron there. So I got to go get this guy set up. We've got to do the complete setup on the mill. I haven't even written a program yet, so I got to get to that too. So let's go ahead and start on it right now. This is what our setup is going to look like. We're going to have G54 here, and we'll have G55 here, so we can put 2 pieces in here. We'll adjust these stops over so that we can slide them into a work stop on both sides, tighten it up, and go to town. We may end up having to put a machinist jack on this. That's what my thoughts were. I'm not sure. I might just go ahead and get a couple of them done and see how the mill and the workpiece performs. See if it tries to chatter and make a bunch of racket on us, but we may need to pinch it just a little bit with a machinist jack. So we're going to go ahead and get this guy set up and ready to go. All right, so we just found the center of both work offsets here, just verifying it with a tape. So 1 inch from the back, and it's going to be in the center of that 6 inch, right in the middle of 3 inches. And then Z0 on the top, and that's the same for both G54 and G55. Well, that was a beautiful thing to watch. We got our first 2 cut. Did those off camera purposely because I need to focus on the job at hand, making sure that we have everything correct before I start fussing with a camera. It looks like we have good parts here. So I haven't even measured it yet. So let's go ahead and grab our rule. Let's just do a quick visual inspection, and we'll hook that hole, and it looks like we are 4 inches. And if we come back here and hook it from the back, you can see that it's 1 inch from the back edge there. So we are good to go. Same thing with that one right there as well. That little Tung Force Rec is doing a great job. I'm going to purposely do a few of these with no coolant for the sole purpose of trying to share some video with you guys. I love sharing this cutting, but after we get a few of these cut and we get some video, I'll go ahead and throw coolant on there so that we preserve the life of our carbide inserts. But let's see some of these guys get drilled. This is awesome. All right, we just pulled the very first piece out, and I was just giving it an inspection. So it looks like the hole goes all the way through, and it does, but there's still just a tiny bit of this radius left in the quarter of the angle that it didn't cut. I mean, it is not much. So I think I'm gonna go modify my depth, my Z depth. We've got it going I've got it going 60 thousandths past the bottom of the hole here. So I need to add another, I don't know, 20, 30 thousandths so that we can make sure we clean that edge up right there. So I think this is going to be fine. I can probably just go in there with my scraper and basically just kind of scrape that out. I can even use a little die grinder if I need to on these first 2 pieces. So we'll modify our program quickly, throw it back in there. Let's go ahead and see a couple more get cut. All right, jump back in here in the Fusion. So here's our part that we modeled up. We just drew a piece that looks like a piece of angle, extruded it, you know, to the length that we wanted, put some holes in it. And so let's go to we're using a 2D bore cycle for the holes. We're gonna edit this. All right, let's see if I can get this right quickly here. This is where we can change our feeds and speeds. On our passes, I'm sorry, is it heights? Okay, it's gonna be the heights tab. Bottom height right here, we've got it set to whole bottom with a negative 60 thousand offset there so that it kind of clears the bottom. So let's go ahead and make that 90. So I'm gonna delete that and put 9. So it'd be about 3/30 seconds, and we'll hit OK. And that should bring it through the bottom a little bit further. All right. Now we can come right here to this one, right click, post process. And yes, we want to overwrite that last file. And there we go. And there's our G code right there. All right, so we'll go stick this in there, overwrite the file, give it another try. Okay, second 2 parts. Our depth is good. It comes all the way through there now, so I don't have that little ledge to worry about. But there's one more change that I need to make, and what I've noticed it's doing is as it's coming down to do the first hole or any of the holes, it's coming down directly on the Z0 surface here as it starts its cut. So I need to change that offset just a little bit so that we start the helical motion down into it instead of it coming down as it's rapiding down and hitting the surface. So that's one thing that I need to go change. I'm gonna make that change and load the program back up, and let's try 2 more. But it's working great, and I'm gonna show you some chip making here in just a minute. Okay, we got you loaded up. So what I did was I changed our Z0 surface for our holes to a positive value. It went up 20 thou. And we're gonna see if that'll work there. So we're gonna go ahead and close the doors and hit cycle start. Let's see you cut a couple holes. Bring it down just to make sure that this is right. Bring it down slowly. Yep. like it's still trying to touch that surface as soon as it comes down. I may make another offset change on that. And you can clearly see as it's cutting to the bottom of that hole, it's really sparking out. I think that has to do with the material itself. That inside area of the angle iron is a little more shiny. It's almost like it's a little harder on the inside of the angle there, right there where it's sparking. Not good on the cutter. So there we go, and that is a 1 minute and 30-second cycle time on both of these pieces of angle iron right there. So that's working pretty good. I think we got a good program. I think I'm probably just going to roll with it. So let's keep swapping them out and getting these parts cut. Just do a little wipe on the workpiece, make sure there's no bandsaw chips. I'm just blowing this out here. Start with G54, get it tight, and then we'll tighten the G55. There we go. I did pull our cutter out because I just wanted to do a visual inspection and make sure that the inserts weren't burned up already, and they're not. They look just fine. So I'm going to continue running like we are, because I'd rather you guys be able to see what we're cutting and sacrifice a few inserts if we need to. I do have a couple packs of these guys ready to go, so if we need to swap them out. Luckily it's only 3 inserts. It's not like you're destroying an entire face mill. Get this oriented right. Okay. For this pair, I do have a couple of jacks underneath the angle there, just to see if it kind of helps with the vibration. I don't think it's necessary because it's doing the job fine, but we're going to see if it helps out anyway with a little bit of those harmonics. Oh, the other thing that I noticed is that, like the last 2 that I did, when it came down in Z and it wrapped and it started cutting, it had the clearance there. On other ones, it still continued to come down and hit the surface. And I think it's because this angle iron, it's not exactly the same on both sides. So depending on how I grab the workpiece and set it in here, this Z height could be off just a little bit one way or the other. I experienced that before doing angle iron, is that you change the height depending on which one of these edges you actually set it down on to work off of. But I think we're good where we're at. That's making some sparkage there. That's not good. I'm going to stop that right where it's at. I just want to make sure that the insert looks fine. Doesn't visually look to be burnt up. The corner doesn't look burnt up. I think it's this material. Spindle back on and wrap it back up to 100. Making sparkles go. All right, so I know that my top height is good where I set that. And these little jacks actually did help reduce the harmonics, so I think I'm going to continue using these. This is just a simple bolt and a nut there on this side because I didn't have two of those little short machinist jacks. But probably need to start running coolant on this pretty soon because I don't want to burn those inserts up and destroy the cutter. That's my biggest worry. Wearing an insert's one thing. I don't want to destroy the, you know, the steel and where I can't use the end mill. So I got about 8 more to cut, I believe. I went ahead and got our flood coolant set up so we can go ahead and run our flood coolant now. So we're not gonna worry about getting any more video inside. Close her up. I think that's gonna help our cutter there. I'm gonna have to hit flood coolant on when I start here. Let's see how it does now. I tightened up those machinist jacks a little bit more too. Sure, we've got some wear on those inserts now that we've cut a few dry like that. So far the coolant seems to be helping. You see how some of them want to spark a little bit more than others. It just depends on where it comes down in that material at. I think we got some bad inserts. It's putting some pretty chewy looking chips out. Come on, let's get through this one. Get through this one, I'll pull that out and check it. Might have to go ahead and index it. Okay, there we go. See up here, we've got 1 minute and 33 second cycle time. So not bad at all. I think we got 6 more to cut. Should be through with them here shortly. But I'm gonna go ahead and work on the end mill here. Probably go ahead and index that because I think we've got the best out of those inserts there, how we've run it. So I indexed all 3 of the inserts. So we did have wear, but it was on the bottom of it. It wasn't the side. So there was definite signs of wear. That's why we were causing so much sparkage there. Anytime you get a bunch of sparks, typically, especially if you're machining mild steel and you're getting sparks, that means the edge of your carbide insert is worn or rolled over or burnt up, and it's causing a lot of extra rubbing. It's really having to work, and all you do is just you keep chewing at the carbide, tearing it up. So fresh corners there. We now have flood coolant running on it. This should get through the rest of those holes and look a little bit more like it's supposed to now. All right, tool installed. Jacks are tight. on. There we go. Now let's see how it, that sounds better. I love those little Tung Force Rec mills. I'm telling you, if you haven't tried them, you ought to get one. They're not very expensive because they're a small cutter. And like I said, you can use them in your manual mill as well. They work great for that. Low horsepower machines. But you can mill with them, drill. You can do a lot of different ops. If you've got to go down into a pocket, they're perfect for things like that. I haven't brought the on-screen drawing over. I hadn't even worried about that. Yeah, that looked much better. Now we got some fresh inserts in there. 1 minute 32. Yeah, the chips, see how the chips look a little more uniform now? Yeah, that's how they're supposed to look. Whenever they come off and they're purple and blue, that means you're getting a lot of heat and you've got a worn out carbide insert there. I'm sure there's a lot of folks watching that understand that, but we throw that kind of info into the videos for the people that are here because they're trying to learn and figure this stuff out just like I am doing with the CNC work here. All right, those look good. Nice shiny holes. I'm gonna go ahead and finish this batch out. We got a few more left to do and we'll be finished up. Okay, well, we've got all 20 of our pieces of angle iron drilled and everything looks good. Our program worked out good. I mean, this went really well there. So we had several really good learning lessons for us here in this job. Every little project that I jump in there in Fusion and work on continues to help me understand it and be a little bit more efficient each time whenever I want to model up a new part and create a CAM program there to put into the machine. So a couple of things to take away from this is to remember that structural steels, just like this angle iron here, is never 100% consistent with this hot rolled material here. So we had different lengths on our leg there. This thickness here changes a little bit here and there, and that changes just as you go down the length of the bar stock. So, you know, you may cut exactly the same, but depending on where this is at, it's going to change thickness slightly. So when you go to put this in the machine, you know, your height or something like that may change just a little bit. It may vary, and you know, so we could easily compensate that by bringing our tool up. But it's just one of those things that you experience and you learn from that, and you realize things that maybe you can do a little bit better next time you get into a job like this. So just a couple little takeaways there. Our Tungaloy end mill here, the Tung Force Rec, did a beautiful job at making those holes. I absolutely love these end mills, and I would highly recommend anyone to pick up 1 or 2 of these and give them a try. Even if you're using a standard vertical manual milling machine, these work really good for there. So I know we did at least half of them, and I had to index the inserts, and that's because I was running it dry and it started burning up the bottom end of the insert there, and that's why we were making the sparkler show for you. So it is better to run these things with coolant, obviously, because you're running these at such fast speeds, but you can run them dry, and typically when you run these in a manual mill, you're not running near that fast anyway. I think my manual mill goes up to about 2,500 or 3,000 RPM, and so you can kind of get away with a little bit more in that situation. But they work really well. You can get these from a diameter of 3/8 all the way up to 1 inch, and I think they go up to 1.25 inches with a interchangeable head there. But really good end mills that I highly recommend from Tungaloy, and this helped get this job done in fine fashion. It was another situation where we had a hole size that I would love to have a specific carbide drill to get this done, but since I didn't have one, and we literally got these this morning and wanted to slam through them and get them finished up, I said, let's try our Tung Force Rec and see if we can use a little helical pattern to get that job done, and it worked out perfect for that. So these are finished up now. I'm gonna get them loaded up and go drop them off at the welding shop. They're gonna be happy to get these back. Just another good example of how, you know, the jobs can change from here and there depending on what comes in. It's never going to be perfect material that you're wanting to cut. It's a lot of times it's going to be structural like this that's a little dirty and nasty and rusty and not really consistent. But lots of good little learning lessons in this job right here. So I hope you enjoyed watching and hope you enjoyed following along, and I hope you come back for the next project. All right, we'll see you guys then.